All right, we're going to begin working with factoring using the GCF. You know the GCF, I hope you know that GCF stands for the greatest common factor. So if we get a problem that looks like this, 20x squared plus 28, and they say factor out completely or factor completely this problem, basically you're just working the distribution property in reverse. You're looking at both parts of these. You've got a 20 and a 28. What do you know that goes into both 20 and 28? Now, some people will immediately go 2. You're right, 2 does, but it's not the greatest common factor. The greatest common factor of these two numbers is 4. Now, if you used 2, it would still work, but you'd have to do more work. Just like if you're reducing a fraction, if you don't use the greatest common factor of the two, the numerator and denominator, you're going to end up having to reduce and reduce and reduce. Here, it's a little trickier. Not so much the work, but what you have to do when you do it. And I'll show you that in a second on this lower part. But right here, 20x squared plus 28. You look at both parts of these. The 20 and the 28 are both divisible by 4. Do either of them, or both of them, I should say, have an x value in them? The first one does, but not the second. So you can't factor out an x. You'll see that on the second one when I go over that, what I mean by that. But here, all you can factor out of both of them, all you can do is divide both of them by 4. 20 divided by 4 is 5, and bring down the x squared. Bring down the plus, and 28 divided by 4 is 7. Nothing, they're both prime numbers, nothing other than 1 goes into both 5x squared and 7. So, boom, put the closing parenthesis. You have factored out the GCF of this, and now you've got the simplified version of that original binomial. Factoring out the 4, this will be beneficial eventually. Right now, it's just being able to factor something out and making something a little easier to work with. 5x squared plus 7 is easier to work with than 20x squared plus 28. Now, what I said before, if you don't use the greatest common factor, you could have said, okay, 2, that makes 10x squared plus 14. But you still look here, 10 and 14 are both still divisible by 2. So you can factor a 2 out of this. But if you factor another 2 out of this, you've got to multiply that one by the 2 that you factor out. That's going to be the 4. That divided by 2 is 5x squared plus 7. And it works out. You can just, it works the same way. You just have to remember that whatever you factor out, you have to multiply that coefficient by that out front for it to work and be correct. Now, the bottom problem here is similar, but I'm looking at this one. We're going to look for the GCF of both of these parts. Plus, we have to look to see if there's anything else that they have in common. Now, some of you are going, ooh, I see what it is, but you may be surprised. They both are divisible by 2, yeah. 4, yeah. 8, yes. They're both divisible by the number 8. So that is a number you could factor out. But they both also include an x. 1x is the most that you could take away from both of them. Now, if you factor out an 8x from this, what is 24 divided by 8? It's 3, but it's a negative 3. And there's 1x remaining because you took 1 away. Minus 2, and you took the 1x away. Guess what's not there anymore? The x is gone. Now, how do I know that works? It's because if I distribute the 8x throughout this problem, like we did with one of those earlier worksheets with the distributive property, 8x times negative 3x squared is negative 24x squared. 8x times negative 2 is a negative 16x. I meant to say negative 3x, not a negative 3x squared. Okay? But this isn't really done completely. Okay? There's a reason I say that. I tried to trick you here. If you look at this original problem, and I'm going to write above it, if I look at this original problem, I not only could have factored out an 8 and an x, but I could have factored out a negative as well. So if I take a negative 8x, this turns into a positive 3x, and the negative sign here turns into a positive 2. That would be a little better. Let me do this so you separate the top part from this part. that would be a little bit better to factor it this way right here. This is good, but you still have a negative that you could factor out of both. Now, you may say, well, what does the negative matter? Eventually, you're going to get to problems where, oh, this would have worked if this would have just been a plus sign and not a negative sign. By factoring out the negative, hey, there we go. We got what we needed with that part. Okay, that is factoring using the GCF. That first worksheet that you're going to get in about 9:10 today.